Good morning. Today we are going to see the last type of this truss, that is indeterminate truss, in which we are going to see the sinking of support. So now we have a truss is in figure is fabricated using members with cross-sectional area as shown in figure. Determinate forces when support B sinks by 0.5 millimeter. So we have given these forces, dimensions we have given. And then we are interested to determine the forces in members, and we have two combination. We have sinking of support also, and we have loads on this also. Now static indeterminacy, R we have 4, DSE we have R minus equilibrium equation equal to 4 minus 3. Then we have 1. DSI is equal to M minus 2J minus 3. And then we have 5 minus 2 into 4 into 2 minus 3 equal to 0. Now we have ds equal to dsc plus dsi, and that is equal to 1 plus 0 equal to 1. Now we have number of redundants, that is equal to ds equal to 1. Consider rb as redundant. So if we will consider rc as redundant, we can have this 0, that is cd and cb, but we cannot go. So whichever support sinks, you have to consider as redundant. As in indeterminate trusses, we have seen the member with temperature change or member with lack of fit should be considered as redundant. In the same fashion, the support which sinks should be considered as redundant, and therefore we have to consider RB as redundant. So we know, so to find P forces, now this diagram we have plotted, that is for P forces. Now as we have to go for P forces, we have to remove redundants, and therefore we have remove redundant. Now we have angle, that is tan inverse of 4 by 4. So this we will get 45 degrees, and tan inverse of 4 by 3, we have 53.13. And then we will start with, now we know, first we have to find zero force members. We have BA and BC, these are collinear. So automatically we have force in member BD, or DB is 0. Now we have joint D with two unknowns only. So we will solve this joint, and then we will have this joint D, FDA, FDC, apply summation Fx0. We will get first minus FDA. We have x component. If we will see two component of this, we are in this fashion. So both are negative because it is in third quadrant. So minus FDA cos 45. Then we have this is in first quadrant, fourth quadrant. So we have x plus, we have y minus. This is my first quadrant. This is my second quadrant. This is third. And then we have this as fourth. So we have first both plus. In second, we have x minus y plus, third both minus, fourth we have x plus y minus. And then we have plus 170, and that is equal to 0. From this we will get first equation, that is minus FDA cos 45 plus FDC cos 53.13, 170 on right side minus 170. And then we will form second equation. Now FDA both minus, so minus FDA sin 45, FDC x plus y minus, FDC sin 53.13, and that is minus 140 left. I have taken directly on right, so it becomes plus. As it is plus on left, goes right minus. So my 140 is minus on left, comes 140 as plus on right. Then we will solve these two equations. We will get FDA 52.53 kilonewton, FDC minus 221.43 kilonewton, and then compression as minus value. So we will show these forces. Now we have to consider, we have to find BC and BA, both are same. So we will consider joint C, because at joint C we have only one unknown. So we have 221.43 as compression, and we have to find FCB. So summation Fx equal to 0. We will get directly value of FCB, that is 132.68 kilonewton tension, and the same we have, that is on BA. So likewise, we have these all as P forces after removing of the redundant. This is the must we have to keep in mind. Remove redundant. If we have internal indeterminacy, then we have to remove redundant member. And if we have external indeterminacy, we have to remove redundant reaction. Now we have to apply this one RB, and then we have to find forces in all members. As we know, we have moment about A0, and then we are going to get RC, that is equal to 0.47. Now we can go likewise also, we will consider BD. BD we will consider as 1 by considering as compression, and knowing this we can go D, and then we can find other also. So here we have calculated 0.57. We know BD we have 1. So now we will consider joint C, and from joint C we will get FCB and FCB. Now we will apply Fy0. We will get value of FDC 0.71 kilonewton. DC or CD we have same, but if we will consider joint C, then we have to consider it as CD preferable. So it shows which joint you have considered. So 0.71 kilonewton, and that value we have, that is plus. Then we have summation fx0. So from summation fx0 minus fcb minus fcd cos 53.13 equal to 0, and we will get it as minus 0.43 kilonewton. So now we will have these values. We can see this. So we have 0.57, 0.543 and 0.71. Now we can go to joint D. So knowing two values, we can find only one value. So, and we will get that values. Now if we will go to joint B, then we should have these are equal and opposite. So BA also we have compression 0.43. Now joint D we will solve just by using summation fx0, because by fx0 we have minus fda cos 45 plus 0.71 cos 53.13, and fda we will get it as 0.6, as value we got plus, so it is tensile. So like when we will get K forces, applying unit reaction. Applying unit reaction. And by applying unit reaction for redundant, we will get all these forces, that is K forces. Support B sinks by 0.5 millimeter, and therefore we have this as dr equal to minus 0.5. So this is millimeters. So only in sinking of support we have value of dr. In all other we have value of dr0. dr0 in all other four types. In all other four types. Because this is actual displacement allowed, and we are allowing 5 millimeter 0.5 millimeter displacement. So same way we have to prepare the table. Now I will not go with this. So we have area, P force, K. So P we have in kilonewton, length we have in millimeters, A we have millimeter square, then we can have PKL, then we have K square L by A, and then PF, and then we will get these values in this way. So AB, then we have BC, then we have CD, then we have DA, then we have BD. Will find summation PKL upon A, and we will get this value minus 219.74. What is unit? Now you can see we have P is in kilonewtons, L is in millimeter, A is in millimeter square, and we will get it kilonewton per millimeters. Then K square L we have. Now KL is millimeter, A is millimeter square. So millimeter gets cancelled. We have per millimeter. And then we will go with dr, that is equal to drl plus f into r, and then we have pkl upon a plus k square l upon a into r. Now we have this as minus 0.5, then minus 219.74. So now keep in mind this is in millimeter. So we have substituted this value, that is in kilonewton per millimeter square. Now this value 219.74, we have kilonewton per millimeter. So now you can see kilonewton gets cancelled. Millimeter square will go numerator and it becomes millimeter square upon millimeter. So we have like this. So your units of all terms should be same. So here also we can have this value, we have per millimeter. This value we have per millimeter square. R we have, so kilonewton per millimeter square. R we have kilonewton. This kilonewton gets cancelled. This millimeter gets cancelled. And we have again this as millimeters. So we have this R, we will get directly 44.51 in kilonewtons. Then we have to find, that is value final forces in the members, and we know we have this formula, that is Pf is equal to P plus K into R. Now if we will go for AB, then we have P as 132.85, value of K we have 44.51, then K minus 0.43, and R we have 44.51. So now here you have to keep in mind, actually your value of dr should be minus 0.5. That you have to keep in mind. Then we have this as AB 132.85 minus 0.43 into 44.51, and we will get this value as 113.71, and as plus, so we have tensile. Then if we will go to BC, we have BC, that is equal to 132.85 minus 0.43 into 44.51. We have same value, that is tensile. Then go CD. CD we have minus 221.43 plus, because we have K plus into 44.51, we will get it as minus. So we have written it as compression. Similarly, we can find for DA, and similarly we can find for BD. And then this is most important we have, that is forces in members. So I can write final forces. Now this 44.41, this is nothing but force in RB, which is 44.51. And then other forces reactions you can find by using this. So now we will stop here only. Remaining part we will see in the next lecture. So thank you.